This video is going to be the second part to using trig functions to solve triangles. And in this one, we're going to be given our two side lengths, but we're going to be missing our angle. So when we're missing an angle, we're actually going to use inverse trig functions. So if you remember from one of our earlier units, we had a notation that looked something like this. F inverse of x, that little -1 is signifying that we are taking an inverse. So we are undoing a function. So remember, we also learned that F inverse of f of x, essentially the inverse and the function cancel each other out, leaving us just with x. So when we are trying to determine what our angle is, when we are trying to get rid of a sine or get rid of a cosine or tangent, cosecant, secant, or cotangent, what we can do is we can use our inverse. So in order to get rid of the sine, I'm going to do sine inverse of both sides. They're going to cancel over here on the left, leaving me with alpha equals sine inverse of 1/2. From here, I could just use my calculator then. A lot of times they have charts that you can look it up and located somewhere in your book. I never use the charts. I just automatically use my calculator, so I would never use that. But then from there, I can use the calculator, and I'll kind of look through these too as we go through. Just like we have sine inverse, we also have cosine inverse and tangent inverse. One thing to also to point out is that sine inverse, that notation I just showed you, there actually are two notations for sine inverse. We can also write arc sine. That means the same thing as sine inverse. In the same manner, if I have cosine inverse, I can also say arc cosine. And if I have tangent inverse, I can also say arc tangent. So let's go ahead. I have two examples here. Let's go ahead and look at these. So on both of them, I'm trying to find that angle measure, that theta. So on the first example, I look at what I've got. I look at this theta that I'm given. From that theta, I can determine that since 12 is across from it, 12 is going to be my opposite side. So 16 is my longest side, and across from my right angle, that's going to be my hypotenuse side. So since I have opposite and hypotenuse, if I look at my SOHCAHTOA, that's going to tell me to use sine. So I'm going to go ahead and say sine of my theta, of my given angle, is equal to opposite over hypotenuse. From here, I'm going to go ahead and take sine inverse of both sides. When I take the sine inverse of this side, sine inverse and sine will cancel, and I'll be just left with theta equals sine inverse of 12 over 16. From here, I'm just going to put this into my calculator. Oftentimes, you have to hit what's called the second button on your calculator to activate sine inverse. Oftentimes, it shares the sine key, but you'll see it written above the sine key in a separate color. In class, when you have some time to work on this assignment, tomorrow I can show you where that button is if you're having difficulties locating it on your calculator. But when I put that into my calculator, I get an answer of 48.590 degrees. And just like in that previous video, how I mentioned we're going to round to 3 decimals, I've got that to my 3 decimal places. Looking at the second example here, letter B. Letter B, I'm asked to do essentially the same thing. So I'm going to start at my given angle, and I'm going to determine which sides I have so then I can pick my trig function. So I see I have the side next to this angle, so I have my adjacent side. Again, it looks like I have my hypotenuse. So if I have adjacent and hypotenuse, I'm going to choose cosine. So cosine of theta is adjacent over hypotenuse according to my SOHCAHTOA. To get rid of the cosine, I'm going to take cosine inverse of both sides. When I take cosine inverse the left, cosine inverse and cosine will cancel, leaving me with just theta. And I'll get theta equals cosine inverse of 5 over 12. Again, from here, I'm going to go ahead and go to my calculator. Putting that into my calculator, And cosine inverse is going to work the same way as sine inverse does. Oftentimes you have to activate that with a second key. It's often found with your cosine button. And again, I can show you that in class tomorrow, but I get 65.376 degrees. And again, rounding to 3 decimal places. So that's the final video for this objective. So we've now looked at if I'm given an angle and a side, can I use trig functions to find the other side? And if I'm given 2 sides, can I use trig functions and more specifically inverse trig functions to find that missing angle?